Hello, everyone. My name is Shreya Verma. I'm Program Manager with SQL Server, and I'm currently focusing on graphs. And today we are going to talk about the graph extensions that we have made to SQL Server vNext. So let's talk about why graph databases are important. People have been using graph databases in social networks and networking systems and logistics for a while now. But recently, they have been garnering a lot of popularity among systems like supply chain management or sales data, where they can use it for recommendation engines, like people who bought this also bought this kind of systems. So, what is so unique about graph databases that make them so popular among different systems? So, graph database allows you to store relationships, and a relational database also allows you to store entities and relationships. But the relationships in relational databases are one to many, and graph databases would allow you to store many to many relationships. For example, a person node in a social network graph can like an organization, can like another person, or like on LinkedIn, you can like another article node. So it allows you to do many to many relationships. They also allow you to analyze interconnected data and identify non-obvious connections in your schema, which helps you to materialize new information from existing facts. For example, let's say the coniferous tree in my backyard is a pine tree. And we know that pine tree is an evergreen tree. From this information, I can draw a conclusion that the coniferous tree in my backyard is an evergreen variety. So now let's talk about the graph extensions that we have added to SQL Server vNext. With vNext, we will allow users to create graph objects. That means now you can create your graph schema, that is, create nodes and edges. There can be properties associated to these nodes and edges. On the slide, you can see very simple graph schema for a preschool, Find Me a Preschool app. You can see the new syntax for create table as a node. We are creating a parent node and a city node. And we are creating two edges, lives in and friends. So every time you create a node in node table in SQL, there will be one implicit column node ID created for you, which will uniquely identify every node in the system. And every time you create an edge, there will be three implicit columns, edge ID, from ID, and to ID, which will tell you which nodes this edge particularly connects. An edge may or may not have any attributes associated to it. Like in the example, you can see that lives in edge does not have any attributes associated to it. There are some query language extensions that we have added to SQL Server vNext, which will allow you to do pattern matching and multi-hop navigation through your graph. In the example here listed on the slide, we can see that I'm trying to find all my friends who live in the city of Seattle. So in the query, you can see the new match predicate that we have added, which has a pattern which I'm searching for through the graph. It just says that find me or my friends that live in the city of Seattle. The match pattern goes from a node to another node via an edge. Anything that is inside the parenthesis in that match pattern is an edge. The entities listed on the ends of the arrows are nodes in my graph. This is fully integrated in SQL Server engine. Queries, if you have your relational schema and graph schema in the same database, queries can look up against existing SQL database tables and graph nodes and edges. And you can also have queries that go across your graph nodes and edges and tables. Along with the storage, along with this, you also get the benefits of advanced technologies that SQL Server currently supports, like column store, advanced analytics, machine learning, and so on and so forth, high availability among one of those. And so you just need to have one system where you run your relational and graph applications together and take benefit of the already existing technologies that we have in the engine. Since this is integrated fully in SQL Server engine, this supports all the security and compliance features that SQL Server supports today. So it will be fully enterprise-grade software. You get the entire tooling and ecosystem for SQL Graph that you get with SQL Server Engine. For example, tools like backup and restore, import and export will just work out of the box. With that, let's just move on to a small demo that we have prepared. It's a small demo for a social network app called Find Me a Preschool. and this will just help parents find a preschool based on what preschool their friends have liked or they are sending their kids to. And all the circles in the schema that you see here are nodes. Like there is a parent node, there's a child node, preschool node, city node, home daycare node. And all the arrows that you see here in the schema are the edges in my system. Like a parent could be spouse of another parent, could be friend of another parent. A parent lives in a city, a preschool is located in a city, and a parent is member of a preschool or a daycare. And parent is parent of child. So let's get to our schema. I have already created a database and created the tables for the nodes and edges. You can see that I have just used the new as node syntax to create the node and as edge syntax to create the edge. The edges may or may not have any attributes to it, like the spouse of edge here does not have any attributes, while is member edge has some attributes, user-defined attributes associated to it. I have already populated some data in this schema. Now let's say I want to find out all the preschools located in the city of Seattle. So I just use the new match predicate to find my pattern, and I want to filter on the city of Seattle. This match predicate will find me all the preschools that are located in any city, but then later on I'm filtering on city of Seattle. So let's execute that. And this gives me this tells me all the preschools that are located in the city of Seattle. Let's see, I want to find out all the people in this app who are sending their kids to a preschool in the city of Seattle. So I'll execute this query. This finds me all the people who are sending their kids to preschool that is located in the city of Seattle. So I run this query and I find out that these 4 people are sending their kids to preschool. Now, out of all these people, I want to find out my friends who send their kids to a preschool in Seattle, because I might be interested in sending my child to the same preschool as that of my friends. So let's say Ron is a person in my graph and he wants to find out all his friends that are sending their kids to a preschool in Seattle. And Ron finds out that Bob and Mary, they send their children to Learning World School, which is in Seattle. And now he wants to find out which is the top rated school in the city of Seattle. So we just write a query, we order by rating, and we find out that, oh, Lakefront Montessori Main Street is the top rated school. Most people like them. One of the scenario which is interesting and which is used by many systems for graph databases is the recommendation engine kind of scenario. People who bought this also bought this. So I have tried to replicate that kind of scenario here. For example, we want to find out any school which has been top rated by people if they also like some other school in the city. Then we want to find out people who like this school who also like other school, because I might not be in the same neighborhood as that school, and I might want to send my kids to a school which is closer to my neighborhood. So I would like to find out people who have rated other schools also nicely, or my friends who have rated other schools also very well. Then I can just run this query and find out. And if you notice in this query, the arrows in the match class can go in either direction depending on the direction of your edge in your schema. One more thing to note is that this pattern in the match class can be as long as you want, but it always goes from a node to another node via an edge. We are very excited to do this, add these graph extensions to SQL Server. We hope that you like it and you find it useful for your applications. Thank you for your time. We look forward to working with you on this.